Hello and welcome to this video on software engineering for blockchain. In this segment, we will introduce you to the basics of software engineering and blockchain technology. Software engineering is the process of designing, developing, testing, and maintaining software. It involves the use of various tools, techniques, and methodologies to ensure that software is reliable, efficient, and scalable. Blockchain technology, on the other hand, is a decentralized, distributed ledger that records transactions in a secure and transparent manner. It is a revolutionary technology that has the potential to transform various industries, including finance, healthcare, and supply chain management. So, what is the connection between software engineering and blockchain technology? Well, blockchain technology relies heavily on software engineering principles to ensure that the blockchain network is secure, reliable, and scalable. In this video, we will explore the various software engineering principles and practices that are essential for building robust and scalable blockchain applications. So, let's dive in and explore the world of software engineering for blockchain. In this segment, we will discuss the software development lifecycle (SDLC) for blockchain applications. The SDLC is a process that outlines the various stages involved in the development of software. It consists of 6 stages: planning, analysis, design, implementation, testing, and maintenance. For blockchain applications, the SDLC process is slightly different. The planning stage involves identifying the use case for the blockchain application and determining the type of blockchain network that will be used. The analysis stage involves identifying the requirements for the blockchain application, including the data that will be stored on the blockchain and the type of consensus mechanism that will be used. The design stage involves designing the architecture of the blockchain network, including the nodes, smart contracts, and APIs. The implementation stage involves writing the code for the blockchain application and deploying it on a blockchain network. The testing stage involves testing the blockchain application for bugs and vulnerabilities, as well as testing the performance and scalability of the blockchain network. Finally, the maintenance stage involves monitoring the blockchain network for any issues and making updates and improvements as needed. By following the SDLC process for blockchain applications, developers can ensure that their applications are secure, reliable, and scalable. In the next segment, we will discuss the importance of smart contracts in blockchain applications. In this segment, we will discuss the importance of smart contracts in blockchain applications. A smart contract is a self-executing contract that is stored on a blockchain network. It contains the terms and conditions of the contract, as well as the code that executes the contract. Smart contracts are an essential component of blockchain applications because they enable the automation of transactions and the execution of business logic on a blockchain network. Smart contracts are written in programming languages such as Solidity and are executed on the Ethereum Virtual Machine (EVM). They are executed automatically when certain conditions are met, such as the transfer of a certain amount of cryptocurrency. Smart contracts are transparent, immutable, and secure, which makes them ideal for use in various industries, including finance, supply chain management, and healthcare. In finance, smart contracts can be used to automate the execution of financial transactions, such as the transfer of funds between parties. In supply chain management, smart contracts can be used to track the movement of goods and ensure that they are delivered to the correct destination. In healthcare, smart contracts can be used to securely store and share patient data, ensuring that patient privacy is maintained. By using smart contracts in blockchain applications, developers can create secure, transparent, and efficient systems that can revolutionize various industries. In the next segment, we will discuss the importance of security in blockchain applications. In this segment, we will discuss the importance of security in blockchain applications. Security is a critical aspect of blockchain applications because they involve the storage and transfer of sensitive data, such as financial transactions and personal information. One of the key features of blockchain technology is its immutability, which means that once data is stored on the blockchain, it cannot be altered or deleted. This makes the blockchain network secure, but it also means that any vulnerabilities in the network can have severe consequences. To ensure the security of blockchain applications, developers must follow best practices for secure coding and implement robust security measures, such as encryption and multi-factor authentication. Developers must also consider the potential attack vectors that could be used to exploit vulnerabilities in a blockchain network, such as 51% attacks and double-spending attacks. In addition, developers must ensure that smart contracts are secure and free from vulnerabilities, such as reentrancy attacks and integer overflow attacks. Finally, developers must ensure that the blockchain network is regularly audited and tested for vulnerabilities and that any issues are promptly addressed. By following best practices for secure coding and implementing robust security measures, developers can ensure that their blockchain applications are secure and free from vulnerabilities. In the final segment, we will summarize the key takeaways from this video on software engineering for blockchain. In this final segment, we will summarize the key takeaways from this video on software engineering for blockchain. First, we introduce the basics of software engineering and blockchain technology and discuss the connection between the two. Next, we discuss the software development lifecycle (SDLC) for blockchain applications and how it differs from the traditional SDLC. We then discuss the importance of smart contracts in blockchain applications and how they enable the automation of transactions and the execution of business logic in the blockchain network. We also discuss the importance of security in blockchain applications and the potential attack vectors that developers must consider. Finally, we emphasize the importance of following best practices for secure coding and implementing robust security measures to ensure that blockchain applications are secure and free from vulnerabilities. By following these key takeaways, developers can build robust and scalable blockchain applications that have the potential to transform various industries. Thank you for watching this video on software engineering for blockchain.